What is the most used man-made material on Earth? You guessed right. It's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic podcast. And I got a fan favorite, Jon Belkowitz with Intelligent Concrete.
It's good to be back. Thank you for having me, sir.
Yeah, man. No, your timing is really good. When you reached out, I honestly was looking out for some topics on restoration, because I believe we're getting to a cycle right now where that's going to be a popular thing again. And maybe the new builds aren't going to be as prevalent as they've been for the last 10, 12 years. And we're going to focus again on concrete restoration. I've done a little bit of it in my career, enough to be dangerous. And I kind of like it because it has some similarities to parking garage construction, as far as sealers and waterproofing and things like that. So I do have some knowledge, but the reason I brought Jon on today is we want to talk about technology, Hydrogel, and Jon's an expert on it. And so Jon, can you explain what Hydrogel is, I guess, to start us off? And
sure.
We'll go from there.
Right. So, when we talk about, deteriorated concrete, and I feel like a politician here because I'm not answering your question right away. There's $42 trillion worth of deteriorated concrete structures that need to be replaced tomorrow.
Yeah, say that number again.
$42 trillion. That's United States. That's only looking at bridges and water reclamation projects that are structurally deficient.
Yeah, that's a big number.
So that's tomorrow. That's not, hey, it'll be 5 years from now. I'm really practicing my one eyebrow thing. It's a shame you're not sharing the video because I'm doing like a good job,
That's the Rock eyebrow, right?
Remember the Rock did not create Dwayne "The Rock" Johnson in the people's elbow. Hell yeah, dude! Okay. But he did not create that. So
was it Belkowitz created that first?
Oh no, heck no! That was like Nicolas Cage,
Oh yeah, Nicolas Cage. Oh yeah, you're right. I wonder if that's where The Rock stole it from.
Definitely stole it from Nicolas Cage. Yeah. So when we're talking about this deteriorated concrete, it's not a surprise to us. The Portland Cement Association says that the leading cause for premature concrete failure and reduction of service life is corrosion of reinforcing steel and corrosion of the concrete that leads to that steel. So we have been, when I say we, I'm using the royal term, the King Arthur term. We have been looking for a way to hide concrete corrosion and mask it and band-aid it for as long as we've been using concrete. And when I say we, that royal term refers to the industry, both engineer, architect, contractor, owner, both, all the above. And what we have done is a very poor job of using Band-Aids. And if you look in a lot of the Department of Transportation's, what they call sealers and healers are really just acrylic-based paints or epoxy coatings. And that's definitely a sealer. I won't argue with that, but it's definitely not a healer. And ultimately what we end up doing is locking in the free chlorides and other nasty sulfates, alkalis, and pour water solution into the concrete. Of course, we're stopping other stuff from getting into the concrete, but the old stuff we're locking in there, and that ultimately causes or creates an environment that is more conducive to that chemical and physical attack. So the analogy that I don't like to use is, but it's great, is if you have a wound, you cut yourself open, the knee-jerk reaction is to cover it up to stop the bleeding. But the correct thing to do would be to clean the wound, apply some antibiotic, and then dress the wound with some type of Band-Aid. And that's just something that we don't do in the industry because we don't really have those technologies to do it yet. And that's where hydrogels come in. And a hydrogel, by definition, is a three-dimensional polymerized network that encapsulates, it's hydrophobic, and it draws and encapsulates water. Hydrogel. Now, this gel can be squishy like Jell-O, or it can be tough and have a high compressive strength, high tensile strength, similar to the calcium silicate hydrate gel that we see in our concrete matrix. So a hydrogel, and I'll stop here in about 10 seconds, maybe 30. A hydrogel starts out as a base technology. It can be a super absorbent polymer that you take from a baby's diaper, or nanoparticles that you have in solution. When that technology is put in the presence of water and some type of second party that triggers this three-dimensional building process, the hydrogel technology destabilizes and the individual particles start building on top of each other, and that's when they grab onto that water. Now, what that hydrogel is made of and the water that encapsulates will dictate how it reacts over time. It just happens to be that there are certain materials that you can use for concrete composites, crack concrete composites, that will trigger that hydrogel process to first bridge the concrete cracks and then eventually heal the concrete cracks. And when we say heal, we mean that the material inside that bridge has a strength and toughness greater than or equal to the parent material or the hydrated cement matrix.
Wow. Yeah. So I thought your analogy was perfect. Yeah. That's as far as the wound and the cleaning and then the antibiotic and then the Band-Aid, or the bandage. So how do hydrogels improve the durability and strength of concrete?
So for Seth, do you see what I'm sharing here?
It's coming. It's thinking. Yep, I've seen this.
When you've seen this. God bless. So when we have cracked concrete, we already know that concrete is a hardened sponge on its best day. Now you start integrating the dynamic forces from use, the chemical and then physical attack from, calcium oxychloride formation, carbonic acid attack, ASR, and then of course, whatever it is, most of those chemical and physical failure mechanisms often lead to steel corrosion. And what's great about concrete is, and I'm not trying to get philosophical here, but concrete is kind of like a human being, right? Every time we create a concrete structure, it's not our child, but there's still a progeneration process where we start out with an empty lot, we clean the empty lot, and then we go through the whole cradle to grave process, and in worst case scenario, cradle to grave process. So there is a human life cycle to this that's very analogous, but the part of it that really that really slams this home for me is the bleeding of the steel. So you ask, how do we heal concrete? I think that was your question, right? How does the hydrogel heal concrete?
Yeah, improve the durability and strength.
Right, to improve durability and strength. Let me just write that down. How does I don't want to lose the question because, like a politician, I often do. How does hydrogel improve durability and strength? Now, as loyal as I am to the concrete material, when you say durability and strength, we're not talking about the concrete. We're talking about the entire concrete structure. Is that
That's
fair?
correct. Yes, okay. Not the concrete itself, because you're trying to repair the condition. So, yeah, as a whole.
Right. So when we look at this phenomena right here, that this breakdown process, how water and contaminants break down a concrete over time, it's a part of the concrete structure. And it's almost like the death by 1,000 cuts, that a concrete structure will not fail because of one crack and one section that is corroding over time. It is, and I shouldn't say that, I'm sure there are cases where that has happened, but normally it's a sum of the parts that make up the damage of the whole. So what we find is this damage is not instantaneous. It happens over time. And in some cases, it's a short time, but it's still a time that we can put a, chronology to. We can see the birth and then the death. And what happens is these cracks that might be superficial at first because of wetting and drying cycles, or just concrete that is way too dry, or concrete that goes through major loading cycles, those superficial cracks end up becoming something that is more deleterious, something that is more service life draining. And as those cracks go deeper into the concrete, remember, we only need 2 inches deep, because the cover of concrete for reinforcing steel is how deep?
Inch and a half, I believe.
Okay, I stand corrected. I thought it was 50 millimeters.
I think it depends on the application, right? There's different clearances for foundations, different clearances for structures above grade, columns. Yeah, depends on what it is. So
depends on what it is. So,
that was a trick question, John.
That was a trick question. So let's just round it up and call 2 inches.
2 inches. That sounds good.
When we're talking about concrete corrosion and concrete cracking, 2 inches is that's not a huge depth of wear. That's not a huge cracking dimension to go through. And what happens is we start, like a human being who's going through some blood loss, we start seeing the lifeblood of the concrete, which really is the reinforcing steel, start to break down and bleed out of the concrete. And it's not normally one singular place. I have this, I'm going to close this presentation. I have this other presentation that I do for universities where I analyze deteriorated concrete. And we go through the whole structural design process of, hey, where did the concrete start out and where is it now when it comes to the failure process? Because as a structural engineer, when you design for reinforced concrete, you're designing for a failure. I mean, that literally is how you design. The assumption is the concrete is going to fail. Now, if you know how the concrete is going to fail, you can design for that failure. And we normally design for a tension or transition zone failure. And what that means is when the reinforced concrete structure is failing, there's running room. There's time for people to get off the structure. What happens is when we lose the steel, which is our tension and flexural component, we go from tension to transition to something called compression zone failure. And that is an immediate and catastrophic failure. You have no running room. Similar to what happened in the condos, Surfside condos in Florida, that was a compression type failure where the building just kind of collapsed on each other. The concrete failed catastrophically, giving people little to no running room. That happens when we corrode our steel to the point that it's not there anymore. And what we can do, to get back to your question, how does the hydrogel impact durability and strength of the concrete structure is once we start seeing that bleeding of the concrete, whether it's a parking garage, a condo, a bridge, lock, levee, spillway, once we see that bleeding and we see the gels coming out with that bleeding, in lieu of just cleaning off the concrete and putting on the Band-Aid, you would put the hydrogels on in between those two steps to act as your antibiotic. And ultimately, when you throw that antibiotic in, just like you had cut yourself, you stop the infection, you start repairing the outer layer and the subsurface of the concrete structure, and you ultimately stop the damage from continuing. And another analogy, it's almost like using Rogaine for minoxidil. You know, for us bald guys,
Yeah.
Rogaine is not going to grow hair back, right? That's just not its purpose. What Rogaine does is it stops the hair loss process. So a hydrogel will stop further deterioration or the impact of the negative nasties that would have on further deterioration of that cracked section. And then you can put your Band-Aid on or
Gotcha.
your wig.
So at what point do you know that you need to apply hydrogel? What is a sign? So is it the like rusting stains that you see on the concrete? Is it a certain size crack? What should folks look out for that would be a great application for hydrogel?
So what we have on our website, so we have a company, Whitney and I started a company about a year ago now called Edyston Concrete. And on our website, we have a calculator that helps you distinguish that, where there's 4 levels of damage. We have a level of damage that has cracking to it, but there's no gels, there's nothing coming out of that. We call that level 1. And then as you progressively increase the amount of gels and then bleeding, you go from level 1 to level 4. So level 1 would be cracking with no gel, no water coming out of the cracks. Cracking with level 2, you would start seeing water, salts coming out of the cracks. And level 3 and 4, you have that increased amount of corrosion or steel bleeding out of the concrete.
So based on that grade of whatever damage that's been done to that structure, is that what determines the dosage and application method for hydrogel?
You got it, man. You got it. Now, bear in mind, this is post-failure. There are some technologies out there that you can use to mix the hydrogel technology. And there's other technologies. There's bacterias. There's polymers that have self-healing. Shoot, MIT just published that crap article on lime cloths being used as self-healing.
Yeah.
That's another conversation, man.
Yeah. That's Roman concrete. We can talk about that another time.
Oh, another time. And I would love. Did you see my video on that, Roman? Oh, okay.
Yes. Yep. But we got to stay on track here. That would probably be a 2-hour podcast by itself.
Dude, just me ranting. So, you know, it's wait, gosh, I forgot where we were at. Was it still talking about the durability of the structure?
No, we were, so you kind of gave us the grades, like a 1 through 4 grade of the damage to a structure. And then I asked you, is it based on that grade of damage, is there a appropriate dosage or application method for each one of those grades as depending on the severity of the damage, I guess?
Yeah, there is. And let me share my screen with you. And of course, it's product to product. So there are other folks who might share that, hey, our technology is different and we don't use that type of dosage, which is fine. But we have a calculator online that you can use. So first, you select the type of structure that you have. So let's say you have a T-beam. And when you hit next, it asks you the type of damage that you have. As it turns out, working with a concrete additive when the concrete is still fresh, so that it is integral to the concrete, it's an admixture and additive, it's pretty hard to diagnose and get the dosage right because you have chemistry differences in the wet state, you have admixture differences. As it turns out with cracked concrete, it's a lot easier to diagnose the impact of problems, and using hydrogels. Gosh, hydrogels are so stupid when it comes to what activates them, but they are so brilliant to the impact that they can have on a body. So with these 4 levels, and really you can diagnose, I mean, shoot, you look at a concrete structure that looks like level 3. I mean, that looks like, sorry, I went too fast. That looks like a traditional concrete structure that I would see in Newark, New Jersey, or Hoboken. Let me go to, I have this University of Victoria presentation. It's a little bit better because it shows, here you go. It shows this failing beam that we did. Okay, let me see. Here we go. So this is the class that we did for University of Victoria. This is a job site that we had to check out. And this is in Florida. This is what a concrete wharf, or just, a bridge, a platform.
Yeah.
And you can see that the underside of it, where the concrete.
You're gonna share your screen?
I did share my screen.
There it goes.
So thanks. So this was part of the presentation that we did. And you can see that you got a whole bunch of concrete beams and girders in here with columns. And where the concrete is failing is in the splash zone, that wetting and drying cycle.
Yeah. So folks that are listening, basically, you can see the where the beams are underneath the deck. You can see the underside of the stirrups in the bottom row of rebar in those beams is what John's showing us.
And it's exposed, and in certain parts, you can actually see the steel cage falling off the concrete.
Holy cow.
And you can also see where they put some, what are those pipe clamps?
Yeah, a big pipe clamp around the concrete column to keep it together. That's
it's not working.
No,
this is what we call in Latin desperation. Now, I'm not a Latin scholar, and I'm not great at translation, but I think desperation means they're doing everything they can to hobble the structure along before it fails down.
Yeah, there's pieces of rebar hanging down from the bottom of the beams. Yeah, that's
So this is what leads us from the tension zone to the compression zone, that catastrophic failure of concrete. So you asked, how does the hydrogel impact the durability and the sustainability of the concrete structure? And that's it. It slows down, or in some cases stops the process of deterioration, because it heals up those cracks before you seal it up. There's always going to be free chlorides and bound chlorides in the concrete, even after we seal it. If we put a patch, if we repaired the steel, put a patch on this, and then painted over it, there's still going to be chlorides in that concrete, free and bound chlorides, sulfates, alkalis. And if we just leave them in there, they're going to destroy the concrete beneath the Band-Aid. The hydrogels use those nasties as a triggering mechanism. The more water, the more nasties in there, the more the hydrogels can build to turn into that gel, which has the same ability as that parent material to protect the steel.
I got you. So does hydrogel, when it hits those, as you put it, those nasties, does it just insulate them or cover them up, or does it absorb them? What's that look like?
It absorbs them and then binds them. Now, it turns out some of the nasties that the concrete grabs onto are calciums that, with the right environment, we can turn into that calcium silicate hydrate, that backbone or superhero of concrete strength. So just like the calcium silicate hydrate does in standard concrete, when we see that hydration mechanism, one of the things that the concrete does to protect our steel, to protect our aggregate from corrosion, is it locks up the water and the nasties that would transmit to the rock for ASR, alkali aggregate reactivity, or steel corrosion. Now, the problem is concrete doesn't do the best job at it because, holy shit, concrete is filled with alkalis, chlorides, and sulfates, especially when we use it out on highways and bridge decks and so on and so forth.
Yeah. So you kind of hit on it, but one of my questions was, so you use hydrogel in addition to whatever other restoration technique that you're going to use. So before you patch it, you're putting the hydrogel in there. So it's
you're cleaning it and then putting the hydrogel. Yeah.
Right. And then you would do like a patch or whatever. So like let's see, I'm trying carbon fiber reinforcement or epoxy or something like that you put on top of that.
Right.
Okay.
So we're working with the Department of Transportation that is using that carbon fiber wrap, which I flippin' love, and people use the hell out of it. And some of the work, we had a bridge. I'm not going to say where in Colorado because they'll know. There was a bridge in Colorado. It was built in the 50s. And the thing, you want to talk about hobbling along, they stopped traffic over this bridge because it wasn't making load ratings anymore. So you think they would rip it out, right? No, they decided to Band-Aid the entire bridge with this, I don't know if it was Quake wrap, but it was something akin to that, it was a carbon fiber wrap with an epoxy paint over it. So the way well, that's cool, John. The way we got involved is they had not tested this stuff to see if it would work before they put it on the entire bridge.
Ooh, thank you.
And it wasn't a big bridge, but I think the definition of a medium span bridge in the United States is like 150 linear feet long. Yeah, that thing was a medium span bridge. Wrap the whole damn thing. They're like, hey, can you test this for us? We need to know if it's going to work. And it did. But anyway.
Wow.
So we've done the pull-off test. What is it? ASTMC 1583. To make sure that, technology like this is not going to impede the bond between the Band-Aid and the concrete. And, normally what you're looking for when you put an epoxy coating or an acrylic paint is failure in the substrate. You want to see that epoxy is going to bind to the concrete so well that it drags the concrete surface with it, not delamination between that interfacial zone. So yeah, you would use this stuff as an antibiotic for a Band-Aid. You would clean the wound, clean the concrete, spray on this technology, and the less wear and tear and corrosion, the less you have to use. And the way it works is you want to spray it on like you would a sealer or a paint or any type of topical admixture where you're going square feet per gallon. So if your listeners have never used that, a dosage rate of 1,000 square feet per gallon is really, really small because you're taking whatever 1 gallon that you have and you're spraying it over 1,000 square feet. So that being said, 150 square feet per gallon is a much higher dosage because you're taking that same 1 gallon and you're spraying it over 150 square feet as opposed to 1,000. So for a cracking that is barely happening, we're not seeing any gels coming out. We're not seeing any salts coming out of corrosion. We're at a dosage rate of 250 square feet per gallon. Now, once we start seeing gels coming out of the concrete, that's when we want to bump that up to 125 square feet per gallon. When we start seeing the steel bleeding out, that's when we used a combined version of the hydrogel, not a standard hydrogel that we've set up. And that's because there's a different level of contaminants that now includes iron oxides and other nasties in it that you have to take into account.
Gotcha. And as far as prepping, is it similar to what you would do, knock off the loose concrete, clean it off? What else do you need to do for hydrogel? Is that essentially it?
That's it. This is not warehouse floors that are brand new, or hospitals or educational centers where you're trying to put on an epoxy or vinyl or a carpet, and that there is a pretty aggressive process that most people don't use. But when you're dealing with new concrete, you got to use ASTMC or ASTMD. What is it, 4258 and 4259, where you're either doing mechanical abrasion or chemical etching of the concrete surface. Here, the technology focuses on the cracked concrete, right? We're not applying this to the entire thing. It's the crack section. Now, if it turns out you have ASR through your entire sidewalk, you want to pressure wash your entire sidewalk. But the technology, when we talk about depth of penetration, and geez, John, you're saying that the technology can get 2 inches deep. Yeah, but that's based on a 2-inch depth crack. If this is new concrete, you don't want to put this technology on new concrete. It's throwing your money away.
Right.
Because this type of technology, at least the one that we're talking about here, focuses on the cracked nature of concrete. It's got to be cracked to shit.
Yeah. So that's for your restoration type of job. It's not for new construction application. We're not replacing sealer or anything like that. We are.
Oh, absolutely not. Now, most sealers and patches, they'll cost in excess of, $100 to $160 per square foot. I keep saying Quake wrap, those carbon fiber wraps with the epoxies, they can cost upwards of $160 per square foot, and that's not counting labor.
Yeah.
A technology like this should cost somewhere between $1.50. I kind of sound like Matt Damon there, or Ben Affleck. $1.50 to $8 or $10 a square foot. It should be a 4 to 6% incremental cost to what you're currently doing, similar to a bacitration or an antibiotic.
Yeah. So when you use hydrogel and you spend that money, you're wanting you're spending that money to extend the lifespan of the structure. So what with hydrogel compared to not using hydrogel, what kind of lifespan extension are you looking at?
Anywhere between 30 to 50% on the minimum side.
Because you're addressing the root cause of the problem, right? You're not just patching over the top of it, pushing it under the rug.
That's a great phrase, the root cause.
That's the root cause.
Yeah, exactly,
right?
Man. I couldn't have said it better. Could not have said it better.
And when you're using hydrogel, is there any environmental or safety concerns using that, or not any worse than probably whatever thing else you're using?
I feel like you and my dad went out for a beer like that. Because this seems like
what you told me earlier about him, I know I'd get along with him just fine.
Oh, he's a great dude. I got some freaking awesome gun stories with him. But anyway, so I'm the inaugural president of this company and CEO. And Dad's like, you got to be like a butcher shop. You got to be like Andy's Meats.
Uh-huh.
I was like, what do you mean I got to be like Andy's Meats? He's like, you got to put your freaking name on top of the door so people know that when they come and go, they're getting meat cut by Andy. I was like, Dad, I'm still not tracking. He goes, I want you to drink that technology. So yeah, we're going to be doing a video where I'm drinking the technology that we use on the concrete.
Cool.
Yeah, no, I don't know how cool it is.
Are you gonna glow?
No. This stuff, it's what I was in the military for a while, and I had to work with a lot of technologies and a lot of products that they didn't tell us was good for us or bad for us. And, I've had to deal with the repercussions with that over time. I used to have a full head of majestic. No, that's not why that happened.
No, you lose that because of kids.
Kids, man. That and Cuban coffee, right? So when we create our technologies, we don't really um, we try not to use any technologies that are going to be worse off than our current concerns with silicosis.
Yeah.
Um, and that is, some people like to blame that on California, but that is a real thing. In inhaling that much silica, and holy moly, guacamole, we rely on silica for concrete. So or ground up and angular silica that often leads to silicosis. When we designed this concrete technology, we did so using food grade products. So the same products that you see in ketchup and beer and wine clarification and a lot of other food products that you eat every day is in this technology. So, hey, it's concrete. You're still going to need eyewear, N95 masks because you are spraying concrete that has some nasties in it. So it's going to be the PPE that you're going to use cleaning the concrete and putting on the epoxy. It has a greater demand than the PPE that you need with this product. Does that make sense?
Yeah. So you're just doing what you normally would do. There's no special handling or anything like that. That's what it sounds like to me.
No special handling, but the handling that you have to do for those epoxies, I don't care if they're water-based epoxies, they all require some pretty, if you get that stuff in your eye, in your nose, in your mouth, you're up the creek without a paddle.
Oh yeah, and it smells to high heaven.
It's that sweet chemical smell that makes you dizzy. I'm about to do, we're building our new facility for Intelligent Concrete. And this week I have to put down 2,000 square feet of epoxy, and we're using a 2-stage primer. And it stinks. It is one of those cancer-causing, VOC having primers. Oh, I'm not looking forward to it. So yeah.
Well, good. Well, I think is there anything else about hydrogel we should know about before we take off for today?
I think I'd be remiss if I didn't suggest that folks go over to our website to learn more. We've got some great animations, some great information on the difference between self-healing and sealing, what a hydrogel is, the animation that shows how they go from cradle to gate, and then contact information if folks want to try this out. It's really a folks can't believe it at first scenario here. This is not an old technology, or this is not a brand new technology. It's brand new to the concrete and construction industry. And not only does this technology have the impact of revitalizing concrete, but it also creates a pacification layer over the steel, ultimately a protective layer over the steel to slow down, and in some cases, stop the corrosion process. And furthermore, we're starting trials right now to see how this technology can be used in soils to create a flashing and a hydrogel-based flashing over full construction joints.
Oh, sounds cool. We'll have to bring you back and talk about that.
Right.
All right. Yeah. So we'll put as usual, we'll put Jon's contact and we'll put Edystone's link in there for everybody. And if you haven't already, go to concretelogicpodcast.com. Join the newsletter. There's a sign up there on the homepage. And that way, when we release Jon's episode and all the other episodes, you get a nice email from me. And we all will send this out to LinkedIn, our LinkedIn community. And also, that's about it. Jon, thank you again. And we'll do it again on something else. Maybe
Roman concrete
rant. All right. Thanks, everybody. We'll catch you next time on the Concrete Logic Podcast. Thank you for tuning in for another episode of the Concrete Logic Podcast. If you'd like to support the show, please visit our website, concretelogicpodcast.com, and click on the show support link. We welcome any amount you can provide. Your support enables us to continue to produce shows commercial-free and free of censorship. As we bring another episode to a close, let's enjoy some sweet tunes by the one and only Mike Dutton.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star Heat to the woods of the Georgia Pine.